Okay, please, you are welcome to Olu TV. Please, if you are new to this channel, please, begging us, please try to subscribe to this channel. Subscribe, please share it and likes. Press that likes, subscribe, please. That's the only way you can help this channel. Now, on today's videos, I will be explaining some indices and some indicial equations and solving a lot of questions on the indices. And I believe that we have learned the law of indices. If you have not learned it before, you should go and learn it because it will help us a lot. Yeah. But I will still be saying it, that the laws of indices, we are going to be coming across them in solving different questions on the indices today. Okay, the one here is number one we're going to solve today. When you have this kind of indices and we are told to find x. Sorry.
Continue.
So if you are asked to find x in this kind of indices, what will you do? Number one, turn this one to index form, 9 to index form. What is the index form of 9? Is 3 raised to power 2. And because of these things, 2x minus 1, put it in the bracket. 2x minus 1 all over. Turn this one also to index form. And since you know that this is 3 raised to power 2, this is 3 raised to power 3. In bracket, x plus 1 equals to 1 all over. Turn this one also to index form. 3 raised to power 2. So after you've done that, just a 3. Now use these two to open the bracket. So that is 4x minus 2 all over 3. Use these 3 also to open the bracket. 3x plus 3 times 1, that is 3. Equals to 1 all over 3 raised to power 2. So after you've done that, according to the law of indices, I say divisional law. Divisional law, you are having the same base. That means the power that is here, you will bring them up when you are having the same base. That means 3, write this one first, the 4x minus 2. So the powers that are here, according to the law of indices, like when you have something like this, a raised to power b over a raised to power c. And what is the law of indices? It will be a raised to power b, when you bring this one up, minus c. Come minus c. So I'm trying to bring this one up now. You start from 3x. What is the sign in front of 3x? Plus. By the time it comes up, it becomes minus. Minus 3x. What is the sign in front of 3? That's plus. By the time it comes up, it becomes minus 3. Equals to. Now, for this one to be balanced with this one, you have to bring this one also up. That will be 3 raised to power minus 2. Raised to power minus 2. But by the time it comes up, it becomes minus. So this base can cancel base. Now we have power here, 4x minus 2 minus 3x minus 3 equals to minus 2. So the 4x minus x, that is x, minus 2 minus 3 minus 5 equals to minus 2. So what do we do with this? We are bringing this to this side. X equals to minus 2 and minus 5 becomes plus 5 here, plus 5. Our x equals to minus 2 plus 5, that is 3. Our x equals to 3. That is the first question. Now let's go to the second one.
Go.
Now, when you have this kind of questions in indices, like the first one we saw, index form. That means 1 all over. Put this one in index form. That is 3 raised to power 4. Open your bracket, should be open. That's x minus 2. Equals to, this is 27 is 3 raised to power 3. 3 raised to power 3, open the bracket, 1 minus x. So the next thing you do is that 1 all over 3. So you are using this 4 to open the bracket. That's 4 times, so that is 4x minus 4 times 2, 8 equals to 3 raised to power 3 times 1, 3 minus 3 times x, 3x. Are very, very important. Now, for you to be able to balance this side and this side, what do? You are bringing this thing up. Somebody's asking me that, but they are not having the same base. Yes, but you can bring it up. If you bring this kind of one up, it becomes 3 raised to power minus 4x. But when this one come up, it becomes minus 4x. Or you can even imagine it like this. You can imagine it like this. Do you know that 1 also can also be written as 3 raised to power 0? Because any 3 raised to power 0 is actually 1. I can say this one is 3 raised to power 0. So by the time I want to bring this one up now, it becomes minus 4x. No, imagine this one is minus 8. By the time it comes up, it becomes plus 8. Plus 8 equals to 3 this power 3 minus 3x. So this base cannot cancel this base. And you and I know that 0 minus 4x is still minus 4x. Minus 4x plus 8 equals to 3 minus 3x. You can now collect the like terms. How do you collect like terms? That will be minus 4x. If I bring minus 3x, that's plus 3x. Equals to 3, I'll bring plus 8 to this minus 8. Minus 4x plus 3x, that is minus x. 3 minus 8 minus 5. You know the minus comes minus our x equals to 5. S equals to 5. Number 3. Evaluate this in indices. How do we do this? Very simple. Put this in index form. Like I said, that's 81 is 3 raised to power 4. 3 raised to power 4. You put this in a bracket. Put this one out. 3 all over 4 minus what's 27? That is 3 raised to power 3 all over 3 times. What is 2 raised to power 3? 2 raised to power 3 is actually 8. That is 2 times 2 times 2. That is 8. Now, imagine after you've done this 4 can cancel this 4. So you have 3 raised to power 3 minus this 3 can cancel this 3. You have 3 raised to power 1 all over 3 times 8, that is 24. Equals to 3 raised to power 3, that is 27. 3 raised to power 1 is 3 all over 24. Then we do 27 minus 3, that is 24 over 24. Our answer is 1. So now the next question is this. Like I said, we are going to solve as many as question other indices, and our aim is for you to get it clear. Now, if you are going to solve this, we know that what is 2 raised to power 0, that is 1, plus, according to the negative law index, that in indices, if you have something like this, so you can say 1 all over 4 raised to power 1. So the minus will leave. Sure you get it. And in indices, don't forget, if you have something like this, 2 all over 3 raised to power minus 1 or minus 2. If I want this minus to go, it becomes 3 all over 2, and this, the minus is good. You just inverting it. And you know that this is affecting both. That is 9 all over 4. I'm just trying to remind us our basic law of indices. So this one now, it becomes 1 all over 4 raised to power 1 all over 2. All squared. Because you know 1 can be 1 over 1, it's still the same thing. So 1 all over 1 plus 1 all over, what is this? 2. Actually, when you see half like this, it means square root. Like when you see 9, so it means square root of 9, that is 3. Or another person will say 3 raised to power 2, and you do like this, not like this, 2 cancel 2. That is 3 raised to power 1, that is 3. Anyhow you want to do it, that's a fractional law. So that means this one actually gives me 2. Don't forget this power of 2 that I said. So we'll now find the LCM. The LCM is 2. 2 in 1, 2. 2 times 1, 2. Plus 2 in 2, 1. 1 times 1, 1. Raised to power 2. That is 2 plus 1, that is 3. All over 2 raised to power 2. Like I've told you, this is affecting this, affecting this. 3 raised to power 2, that is 9. And 2 raised to power 2, that is 4. And that is 9 all over 4. 9 all over 4. Now the next. Now, this is another question on that indices. It's under your fractional law. I'm going to break it down so that you understand how to tackle any questions on that. Now, what you do is that this you can split it first like this. Cube root is 7 a raised to power minus 9 all over cube root. This cube root is meant for this and this. That's the first thing you have to know. The next thing you have to know is that these are two things. Do you remember the law that they give like this, that when you have something like this, cube root of a, so it's the same thing as a raised to power 1 over 3. This one will come under this. And also, if they give like this, something like this now, let's say you have something like this, They say cube root A, and now put 2 here. I'll write it. It becomes A, this 2 will be, this 3 will come here. As you can remember. Also the same thing, if they have given like this 2/3, that means you want to write it like this, it become like A, this 3 will come here as cube root, and this 2 will stay here. According to our law of indices. Okay, now that we know that, you can now change it. For this 27 now, it will be 27. This cube root will become 1/3 here. 1/3 here. For a raised to power minus 9, a raised to power minus 9, this 1/3 also will come. As simple as that, the cube root for this and the cube root for this. All over cube root for the 8. Because it will now become 1/3 back. As simple as that. So we can now do our index after we have broken it down to that extent. Index of 27, that is 3 raised to power 3 over 3 times A raised to power minus 9, 1/3. No, 3 here 1, 3 here 3. All over, put this one in index form. 2 raised to power 3, 1/3. This cancel this. So then this cancel 3. Then we do 3 raised to power 1 is 3 times 3 here 1, 3 here 3, A raised to power minus 3. All over 2 raised to power 1 is 2. That is 3A raised to power minus 3. All over 2. So, but in some cases, they will not like you to leave the answer like this. What do you not do? So, when you have 3A raised to power 3 all over 2, so you can bring this one down. If you bring it down, it will become 3/2A raised to power 3. Understand the index form. When you have 1 all over A raised to power 3, you want to bring it up to become A raised to power minus 3. But when you have A raised to power minus 3, you want to bring it down to become 1 over A raised to power 3. Like the law of index form. So that is that for that. Another question from you. Now, when you have something like this, we should simplify this. What do we do? That is 5 raised to power x times, put this guy in index form, 5 raised to power 2, open a bracket, x minus 1, all over, put this guy also in index form, 125, that is 5 raised to power 3, into bracket, x plus 1. As simple as that. What's the next thing to do now? So you just say 5 raised to power x times, like I told you earlier, use that 2 to open the bracket, 5 2x minus 2 all over 5. Use the 3 to open the bracket, 3x plus 3. So after that, according to your law of indices, when the base are the same like this, you pick one, you add the powers together. That means it will become 5. You add the power x plus 2x minus 2. All over this 5 is power 3x plus 3. So the next thing we do now is that equals to 5. Now x plus 2 is 3x minus 2 all over 5 3x plus 3. As I've told you earlier, according to the divisional law, they are the same. Pick one and you bring this power up. So that means 5, write this one first, 3x minus 2. By the time you are bringing this one up, the plus here will turn to minus 3x. By the time you are bringing this one up, the plus here will turn to minus 3. So our answer will be 5, 3x minus this plus 3x cancel minus 3x. Minus 2 minus 3 is minus 5. Our answer is 5 raised to power minus 5. But you may not leave the answer like that in negative index. So what you do now is that we have 5 raised to power minus 5 become 1 all over 5 raised to power 5. Cool. Now the next question is on indices again. Now what is we here? That's 2, the power of power. there's one law of indices that says power of power. You just multiply the powers with the power. Now this is a power and another power. That is 2x times 3, that is 6x. 3x times 2, that is 6x. All over 6 raised to the power 6x. So what you now do now is that if you notice in indices that the powers are the same, but the base are different. So what you do is that you pick one. The way when the base are what's it called, the same, that you pick one and you add the powers together. In this case, you will pick one out of the power that are the same. You will not multiply the base together. That's it. That's another thing. That means 2 times 3. So you pick one out of the power. That gives 6x all over 6 raised to the power 6x. What is now 2 times 3? 2 times 3, that is 6. 6 raised to the power 6x all over 6 raised to the power 6x. Answer is 1. As you can see, they are the same. It's 1.
Oh.
Now, when you have something like this is actually under the initial equation because you are already having the equals to. Now, what if this is still the normal process? Put this in index form. That's 5 raised to the power 2 x minus 1 equals to, this is actually 64. Like I told you that this, whenever you have a power here, it's having impact on this and this. So what you do is you can say 5 raised to the power 6 all over 2 raised to the power 6. So what you do is 5, use this one to open the brackets. 2x minus 2 equals to, if I were you, I know that this 2 raised to the power 6, and I know 64 also is 2 raised to the power 6. So that means 2 raised to the power 6, 5 raised to the power 6, 2 raised to the power 6. This will cancel this eventually. That means 5 raised to the power 2x minus 2 equals to 5 raised to the power 6. So this is going to cancel this. So we are having 2x. Having 2x minus 2 equals to 6. So bring this one to the back here. That is 2x equals to 6 plus 2. 2x equals to 8. All over 2, all over 2. Our x equals to 4. X equals to 4. And the next question. Okay, now solving this also in the equations because it's equals to, what if these are 3x, like I told you, this means 1 over 2. So that means if I say times 1 over 2 here equals to 9, I'm going to say 1 over 2 here. So that means 3x over 2. You know that what's square root of 9? That is 3. I can just say raised to the power 1. 3 cancel 3, I can say x all over 2 equals to 1 over 1. You can just say this 1, the power equals to power. Just cross multiply x times 1, that is x. And 2 times 1, that is 2. Our x is 2.
Oh.
Now, when you encounter this kind of indices, what do? You have to know that when you see something like this in indices, 5 raised to the power x plus 1 can also be rewritten as 5 raised to the power x times 5 raised to the power 1. You have to know that it's still the same thing. Because when I pick one out of this base, I'll add the powers together, which also is going to give me this. Definitely, I can just, here now, I'll say 5 raised to the power x times 5 raised to the power 1 plus 5 raised to the power x equals 150. I may not put the 1 because anything 5 raised to the power 1 is still 5. So if you notice, math students, you will discover that this is one side, this is another side. Because 5 raised to the power x times 5 is one side, plus separates them. Because in mathematics, you can as well say AC plus A. And what you notice, you can factorize, you can say A into bracket C plus 1. Because this AC also means A times C, which is what you see, and it's AC. And you can also write it as AC. And when you factorize it, because A is common, so the C, A times C plus A times 1 A. So what you now do, like that. That means 5 raised to power x is common to the both side. So I can just say 5 raised to power x into brackets 5 plus 1 equals 150. Plus 1 equals 150. So after I've done that, what do I do? That means 5 raised to power x, 5 plus 1 is 6 equals 150. So what's the next thing? I'll divide both sides by 6. All over 6. All over 6. 6 cancel 6. 5 raised to power x equals 6 here 1, 6 in 1, 15. That is 2. Remember 3. 6 in 30. That is 5. So I can just say 5 raised to power x equals to 5 raised to power 2. If I put this in index form, 5 cancel 5. Our s equals to 2. Our s equals to 2. And the next. Now in this case, when you see something like this one will be 5 raised to power x 40 all over x. Like this one come under this. 1 over this. To come under this, and actually it will happen like this. Now I'm bringing this for this power, and I'm bringing 5 under this. That means the power here, x all over x. Let me drop my hand. That means x all over this equals to 40 over 5. I put the power down here. So the next thing now we do now is that, as long as this one is raised to power 1, that means 1, by the time you are bringing this one up, 1 minus 1 all over 2 equals to 8. Now what we will now do is that, if you find the LCM, so definitely we're going to have x 1 over 2 equals to 8. And you know that what's 8? That is 2 raised to power 3. Now in this case, what do you do? Now you take the inverse of 1 over 2. What is the inverse of 1 over 2? That is 2 over 1. You use it to multiply both sides. And it's 1 over 2. Inverse of 1 over 2 is 2 over 1 equals to 2 raised to power 3 times 2 over 1. The inverse you use here, you are still going to use it for the other side. That's how it goes for every mark. These two cancel 2. That means x equals to 2. 3 times 2, that is 6. 2 raised to power 6, that is 64. Now, this is another one, 9 indices. They ask us to solve for x. Do not forget that this is not cube root. This 9 is standing out alone. So what can we do now? I can just say, I can square the both sides. In this case, square the both sides. And square the both sides, that will be s squared equals to, you know this square, we have read this, that's 81, and it will cancel this. So we are having 9x left. So after that, s squared equals to 3 raised to power 4 to bracket 3 raised to power 2 x. Now, if I were you, I would just bring this under this. I wish this x variable side, I'll just say all over x. This will cancel this automatically. So that means we are having x raised to power 2 all over x 1 over 2 equals to 3 raised to power 4. So when you multiply this, you know, you take 1, you add the powers together, plus 2. You don't need to waste time. So now, in divisional law, bring this one up. That will be x raised to power 2 minus, when this one come up, minus 1 all over 2 equals to 3 raised to power 6. Now this one is all over 1. When you now find the LCM, you're going to have XM is 2. 2 in 1, 2 times 2, that is 4. Minus 2 in 2, 1, that is 1, that is 1. Equals to 3 raised to power 6. That is X, 4 and that is 3 all over 2 equals to 3 raised to power 6. So I told you in our previous one I saw that when you experience this kind in mathematics, you take the inverse of this and you also use for this. What's the inverse of 3 over 2? That is 2 over 3. That is 3 over 2 times 2 over 3 equals to 3 raised to power 6 times the inverse 2 all over 3. This 3 cancel 3, 2 cancel 2. Our aim of using inverse is to make sure that we eliminate this. That means the x will stand alone. So 3 here 1, 3 here 2. 2 times 2, that is 4. Our x equals 3 raised to power 4, that is 81. 81. So now this is another question on indices. So what we'll do is that according to the negative index, when you have something like this, if you want it to come down, that will be 1 all over s squared. So we have to take note of that. So this will become 8 all over s squared because it has come down equals to 2 all over 25. So what do? I'll cross multiply. If I cross multiply, that will be 2s squared equals to 25 times 8. That is 2s squared equals to 8 times 5, 40, and 4, 8 times 2, 16. 16 plus 4, that is 20. So we divide both out by 2. So the s squared equals to 100. So find the square root of x. So that is our x is 10. Our x is 10. Oh. So this guy will become 4 raised to power minus 1 times the off will become times 4 raised to power 2 into bracket minus 2x plus 1 equals to 4 raised to power 3. That means 4 raised to power minus 1 times 4 raised to power minus 4x plus 2 equals to 4 raised to power 3. So pick one out of this, you add the powers together. 4 minus 1 plus open bracket minus 4x plus 2 bracket all 4 raised to power 3. So the base we cancel base. So you have minus 1 plus x minus 4x plus x plus 2 equals to 3. The power we equate the power. So that means minus 1 plus 2. That is 1 minus 4x equals to 3. If I collect like terms, the 1 will come to this side. Minus 4x equals to 3 minus 1. Minus 4x equals to 2. 3 minus 1 is 2. And we divide both sides by minus 4. All over minus 4 over minus 4. Let's cancel this. You have x equals to 2l1, 2l2. That is minus 1 all over 2. Okay, so this guy will be 10. You know, like I said earlier, that 10 raised to power y can also become 2 times 5 all raised to power y, because I want to target the 5 and I want to target the 4, because actually I will turn this one to 2 raised to power 2. So I'm trying to target this and this. So I have to split this guy in this sense. So that means if this is 2 times 5 raised to power y times 5 raised to power 2y minus 2 times 2 raised to power 2 into y minus 1 equals to 1. So definitely we can say 2 raised to power y times 5 raised to power y times 5 raised to power 2y minus 2 times 2 raised to power 2y minus 2 equals to 1. So what will I do? So I want to bring 2 and together and 5 together. That means 2y times 2 raised to the power 2y minus 2 times 5 raised to the power y times 5 raised to the power 2y minus 2 equals to 1. So I'll pick one out of these two bases and I'll add the powers together. 2 times y plus 2y minus 2 times 5 bracket y plus 2y minus 2 equals to 1. So that means 3y minus 2 times 3y minus 2 equals to 1. As you can see that the powers are the same. So what you do is that you multiply this, you pick one out of it. That means it will become 2 times 5 into, you just pick one out of the powers that are the same. 3y minus 2 equals to 1. That is giving us 3y minus 2 equals to, you can change it also to 10 raised to the power 0. 10 raised to the power 0 actually will give us 1. This cancels this. So we are having 3y minus 2 equals 0. If I collect the like terms, that is 3y equals to 2. All over 3, all over 3. And y equals to 2 all over 3. Okay, these kind of equations in indices. Now, when you notice something like this in indices, now when you see 2 raised to the power, you see something like this, you see something like this, mostly the same. The next thing you have to think about is that how to make this one to be the same like this. So you can just say 2 raised to the power x plus 32. You know, if I say 2 raised to the power x minus 1 minus 12 equals 0, it's still the same thing because minus 1 times x is minus x, power of power. There's a law in indices that we call power of power. Now that you have made this one to be the same with this one, now represent it. Represent 2 raised to the power x to be y. So that means anywhere I see 2 raised to the power x, I'm putting y. That means y plus 32. I see 2 raised to the power x here. Y minus 1 minus 12 equals 0. So that means I can do like this: y plus 32 all over y minus 12 equals 0. What did I just do? Because this is negative index, y minus 1 equals y 1 over y. And it actually have to come under this. All over 1 over 1. So the LCM is y. So y in 1 times y times y is y squared plus y in y 1 times 32 minus 12y equals 0. So if I cross multiply, so I'm going to have y squared plus 32 minus 12y equals to 0, because y times 0 will actually end up in 0. So I want to solve it quadratically. But before you do that, you can rearrange y squared, bring this one minus 12y plus 32 equals 0. So that means we are solving this thing quadratically. That means this times this 32y squared. Now what are the two numbers that when I multiply it, it will give me this, and when I add it, it will give me this? That will be 4 times 8. 4 times 8 is going to be minus 8y minus 4y. Minus 8y minus 4y will give minus 12y. And when I multiply them together, it will give me this. Minus times minus is plus 8 times 4, 32, y times y squared. So the next thing to do now is that let's say y squared minus 8y minus 4y plus 32 equals 0. Y into bracket y minus 8 minus 4 into bracket y minus 8. So we have y minus 4, y minus 8. So if I equate this one with 0, it's going to give me y equals to 4. If I equate this one with 0, it's going to give me or y equals to 8. But do not forget that we represent 2 raised to power x by. So we should not forget that. That means since we represent, so we are going to say anywhere I see y, it is 2 raised to power x. That is 2 raised to power x equals to 4. That's 2 raised to power x equals to 2 raised to power 2. This cancels this, x equals to 2. And also here, y is 2 raised to power x equals to 8. And it's 2 raised to power x equals to 2 raised to power 3. 2 cancels to our x equals to 3. So that was that.
Oh.
Now, let's look at something like this. They are very simple because they are same base. Take one, add the powers together. All over this equals to change this one to index from 2 raised to power 3. So definitely we have it 2, 1, no plus 1, here we cancel minus 1. And minus y we cancel plus 1. So that means 2 y plus 2 equals to 2, 3 times 2, 6 minus 9y. So definitely 2, when this one come up, to come minus y minus 2. Plus is here, become minus y, plus is here, become minus 2. Equals to 2 raised to power 6 minus 9y. This cancels this. We have 1 minus y minus 2 plus 6 minus 9y. So if I collect like times, 1 minus 2 plus 1 minus 2, that is minus 1 minus y equals to 6 minus 9y. So I can say, if I collect like times, minus y plus 9y equals to 6. If I bring this one here, plus 1. Minus y plus 9y, that is 8y. Equals to 6 plus 1, that is 7. Over 8 over 8. And y equals to 7 all over 8. Now, anytime you meet with something like this in indices, take away this minus. And how do you take away this minus? Just interchange the fractions. So it's become 16 all over 81. How will I take away this minus? It becomes 1 all over 2 raised to power 1. And 2 raised to power 1 is also 2. So this, whatever you see here belongs to this and this. That's 16 all over 81 times 1 all over 2. So actually this means square root. It means square root. When you see something like this, it means square root. You need this, which is 4. Or you can also do like this. 2 raised to power 4 and 2 here 1, 2 here 2. And 2 raised to power 2 is not 4, it's still 4. Anyhow you do it. So that means this is 4 all over, what's square root of 81? That is 9 times 1 all over 2. Or the same way you can also say 3 raised to power 4, 3 raised to power 4, 1 over 2. 2 here 1, 2 here 2. 3 raised to power 2, that is 9. So the same way. So that means 4 times 1, that is 4. 9 times 2, that is 18. So, simple as that.
Again.
Now, I'll advise you, when you have something like this in indices, since everything is in the bracket, raised to power minus 1, so you can just say 1 all over. So the minus will go cube root of 64 a raised to power 3. All of them will come down because they are all in bracket. Now, like I explained, now this 1 all over cube root for this and cube root for this. 64 for this, and also for the a raised to power 3, the cube root also will come for this. Definitely you don't have 1 all over. And 64 is actually 4 raised to power 3. 4 raised to power 3, 1 over 3, and this a raised to power 3, 1 over 3. This cancel this cancel this. So we have 1 all over. 4 raised to power 1 is 4, and a raised to power 1 is 8. 1 all over 4 over 8.
Cool.
Okay, now in this case, so they just say we should evaluate without using tables. 343 is usually 7 raised to power 3. I target this. And in case you are finding it hard to know the index, just be using this. So it will help you. So the times, I have to change this one to fractions for me to find it easier. You know, tenths, after decimal point, you have tenths, after tenth, hundredths. That is 14 over 100. Raised to power minus 1 times this guy is having minus z, can put 1 over 25 raised to power 1 over 2. Okay, follow the normal method. 3 cancel 3 here. 7 raised to power 1, that is times. Now, if 1 is minus to go, just interchange. 100 all over 14 raised to power 1, which is still the same thing. Does not have any impact. 1 all over. I told that this one means square root. Square root of 25 is 5. But it's still the same thing as 5 raised to power 2, 1 over 2. 2 cancel 2, 5 raised to power 1 is still 5. So that means we have over 1 here, 7 here 1, 7 here 2. 5 here 1, 5 in 100. That is 20. So 1 times 20, 20, 20 times 1 is 20. All over 2. 2 times 1 is 2. And 2, that is 10. So please, thanks for watching. This is just 21 solving questions on indices. All these questions being solved, they are meant for Jamb. If you want to write down, you can go through them. If you want to write Waec, you can go through them. Neco, you can go through them. And all these questions, if you go through them thoroughly, it will give you a basic and thorough knowledge of indices. That anywhere you handle any indices questions, you'll be able to know what to do and even to get it properly. Please, the best thing you can do for this channel is to please, as you're watching, subscribe. When you subscribe, make sure you like it and you put a comment. Please, we need a feedback, and share it to your friends so that this page can actually, for the continuity of this page and to encourage, the content, creators of this page. Thank you so much for watching. You're welcome.